If you're completely new to Unreal Engine 5, turn on bell notifications. I'm working on a tutorial for you. To follow this tutorial, you do need some basic understanding of blueprints. By the end of this video, we will make a first-person character, first-person locomotion with the grappling hook, wall run abilities, realistic headbob camera shakes, double jump, smooth crouching and sliding, dash ability with field of view effects, and a trampoline. Also, I have launched a Patreon. If you enjoy my tutorials and want to support me, check it out. As a bonus, you can download the finished project files from this tutorial and more on Patreon. Your support will help me keep creating awesome content for you. Let's get started. Let's make double jump in Unreal Engine 5. It is very simple and easy to do. Let's get started. Let's make a new Unreal Engine 5 project. From games, I will select the first person template and name my project first person game. Create. Now from the content drawer, let's go to the blueprints folder. Here in the blueprints folder, let's select this BP first person character. Double click to open it. Now let's arrange this tab here. If we scroll, we can find the jump logic. We need to change this logic in order to add ability to double jump. Now, two nodes will be very useful for us for adding double jump easily. One of them is do n. I'm going to type here do n without space. Here is this. This node allows us to do anything that is connected to this pin n number of times. I'm going to enter 2 here. So it will allow us to do whatever we connect here 2 times, and then it will not allow us to do it again till we reset it. So if we jumped twice or if we double jumped once, we won't be able to jump again if we don't reset it. So we will have to reset it as well. Also, it gives us access to this counter, a number that will be 1 on the first run, it will be 2 on the second run, and so on. Now there will be another node that will be very useful to us, and it will be switch on integer, switch on int. This node lets us do different things based on different values of a number. We need to add some pins. I'm going to add 3 pins here. We're not going to use this 0 pin here. We will use only 1 and 2. Now based on this number, it will let us do these different things. So if it is 1, it will let us do this one, whatever is connected to this pin. If it is 2, it will let us do whatever is connected to this pin. So let's connect this counter to selection. That way, if it is the first execution, if it is the first run of this after reset, if it is the first run of this node, the selection here will be the counter, which will be 1. So it will let us do whatever is connected to this pin here. And on the second time, similarly, it will let us do whatever is connected to this pin here. Let's connect the exit to switch on int. Now I'm going to right click here and break this link, and I will take this jump and connect it to the first pin here. Now I'm going to click here on this little arrow, and we are going to connect this started pin to this 2n. Enter. I will collapse it again by clicking here. Now when this selection is 2, I want to use a different node for the second jump, and that will be launch character. This node allows us to add some velocity to our character, and I will add some velocity on the Z direction. Let's add 600. Now again we want to reset this, else if we don't reset it, we won't be able to jump more than 2 times. So let's look for event on landed. So when our character is landed, we want to reset our to end node, that is for the double jump. Now this is how easy it is to make double jump in Unreal Engine. Let's try it. Compile, save, go to the map, play the game, and if we try to jump, so we can jump twice, and if we try to jump more than twice, we cannot do that till we land. And if after we land, we can jump again, we can double jump, we can jump once. So this is how we can add double jump in Unreal Engine 5. It is this simple, and we are done here. But after this, I like to do 2 more things. The first thing is, I don't like the default gravity for my project. So I'm going to increase the gravity scale. So if we go back to the first person character blueprint, we have this character movement component here. If we click here, we can see gravity scale. Now for my project, I like 2.3. You can keep it to 1 if you want. And if we change this gravity here, then I don't use this jump here. I like to use the same launch character node here. So I connected both 1 and 2 to the same node, launch character node, because I want both of these jumps to be kind of similar. And instead of 600, I will make it 900. If you don't have any reason to change the gravity scale by default, it's probably a better idea to keep it at default value, that is 1. But for my project, I just like this 2.3 value. So we have to be careful when we change the gravity scale. If we are also changing it in the blueprint in some other place, we have to keep track of the original value and so on. Now you don't have to do this. It's just something that I like to do for my projects. So I changed the gravity to 2.3. I connected both of these pins to the same launch character node, that is launching in the Z direction with 900 velocity. Let's try it. So I like this one better. You can try different numbers and see what works well for you. So this is our double jump in Unreal Engine 5. If you liked my video, please subscribe to my channel and share my videos with your friends and fellow game developers. I will see you in the next video. Have a great day. Hey guys, I hope you're doing well. Let's make first person wall run in Unreal Engine 5. It's very simple and it is fun. I like it a lot. Let's get started. Hey guys, we are in the first person template and we will make wall run. From the content drawer, let's go to the blueprints folder and open the BP first person character blueprint. Here I have already added a simple double jump logic in the previous video. If you are interested, you can check it out, or you can follow along without that logic if you want to. So first let's go to the viewport because we want to add a collision. Here with the capsule component selected, let's add another capsule collision. I want to scale it up a bit. Before that, let's name it detect wall capsule. To scale it, I will press R key on my keyboard. With focus here, I will press R key on my keyboard. And I will hold this little cube here, so I will scale it in all directions. Let's see how this looks. I want to check it from the top. I think this needs to be a little bit more on the X and Y axis. This looks fine, I think. From the left, this is too much. Let's scale it down a bit. I think this is fine. We will come back to the viewport later when we add the camera rotations. For now, that is all we need to do in the viewport. Let's go back to the event graph. With this detect wall capsule selected, in the details we want to look for on component begin overlap. Now we want to have a tag on our wall so we can detect if we can run on this particular wall. Let's say we will call that tag wall run. So we want to check it. To check it, let's drag from other actor as tag wall run without space. I will press B on my keyboard and hold the key and click here. This will give us a branch. So we want to check if we are not on the ground, because we don't want to start the wall run if we are standing or just running and not jumping. Okay, to check that, we can get character movement and say is falling. So this tells us if we are in the air, not on the ground. If our detect wall capsule is overlapping with an actor that has a tag wall run and we're not on the ground, then we want to start the wall run. So we will get an AND boolean. If both of these conditions are true, then we can start the wall run. Let's get a boolean variable. So I already had some variables here. I just deleted them. I will make it again for this tutorial. So let's get some variables. Let's make a new variable that will be a boolean. So the type is boolean. Let's call it is wall running. By default it is false. Here we want to set it to true. Let's get another variable. This will be a vector. We will call it player direction. This will be the direction that we want our player to move while we're running. It will be a vector. We need to set this as well. To find the player direction, we can look at the dot product of the wall forward vector and our first person camera's forward vector. So if the dot product of these two vectors, if the dot product of our wall's direction and our camera's direction is greater than 0, then they are pointing in the same direction. And if the dot product of our wall forward vector and our camera forward vector is less than 0, that means they're pointing in the opposite directions. We want to get the other actor. I think we can double click here and drag from here itself. Now this is our wall actor. This is our wall. Now we want to get forward vector. This is the direction that our wall is pointing to. And we will get the first person camera. We will get its forward vector. This is the direction that our camera is pointing to, that we are currently looking at. If they are roughly the same direction, that means the dot product of these two vectors is greater than 0. We want to move in roughly the same direction. We can actually do it using a simpler node, that is select int. So we can select an integer based on this condition. So if it is greater than 0, then we'll pick A will be 1. It will be the same direction or as our world direction. Else we'll pick B, which will be -1, because we want to go opposite to the world direction. When we're wall running, if we are facing in roughly the opposite direction, then we want to go opposite to the wall. So let's get the wall's forward vector and we will multiply it by either 1 or -1 depending on the direction. And this will be our player direction. Let's select this and comment it. Set player direction to wall direction or opposite wall direction based on angle between them. I want to change the color. I will select slightly pink color here for this one, for this node. This looks good. I will save it and then okay. Now we also want to use something called plane constraints that will help us restrict the movement of our player while it is wall running in only X or Y directions. We do not want to move in the Z direction when we are wall running. So in begin play, we also have to enable plane constraints. Let's do that. Let's get begin play. Let's get it here. We will use set plane constraint enabled. It will be from the character movement. So if you don't get it here, you can get it with the character movement and say set plane constraint enabled. And yes, we want to tick it. We want the plane constraint to be enabled because we want to use it later. Here also let's get character movement and say set plane constraint normal. This time we will set the normal because we want to make sure that our character is not moving in the Z direction. So we will set the Z to 1. We can only move in the X and Y directions. We also want to set the gravity scale to 0. So let's get the character movement again. Let's say set gravity scale to 0 because we do not want gravity to affect our player while we are wall running. With this, we also want to make a new variable. Let's say old gravity scale, because we will have to revert this change when we are done wall running. So let's get it a float, a new variable, old gravity scale. And in begin play, we will set the old gravity scale to whatever our character movements gravity scale is. By default this is usually 1, but in my project I have set it to 2.3, so I will be doing this. It will be helpful later when we have to reset our gravity scale. Now we need a timeline. Timeline is like a custom event tick that you can use inside your blueprint. Let's say this will be wall run timeline, and let's connect it to play. Let's go inside the timeline. For now we don't have to add any tracks, we will just make sure that this timeline loops. So we will click on the loop here, compile, save. Get back to the event graph. When the timeline updates, we want to get the character movement and set velocity. We will set the velocity vector here when it is updating. Now to calculate this, we want to get our player direction and multiply it by some number. I will change this to float. For me, the number that works is 2500. It can be a different number for you. So you can try with different numbers and see how you like it. Now, because this is a looping timeline, this will not end if we don't stop it. So we have to stop it. For that, we will do it when our detect wall capsule is off the wall. So we can select the detect wall capsule and look for on component and overlap. Again, we have to check if the other actor has tag wall run. This has to be same everywhere without spaces. And we can get a branch. Let's drag it to the right position. Now we want to do two things. So we will get a sequence that will let us do many things. So if it is true, we want to do two things. First, we want to stop the timeline. Then we want to reset the variables. So first we want to reset the plane constraint normal. So let's get the character movement and set plane constraint normal. All of these will be 0. Now we want to reset the is wall running variable. This will be false. And we also want to get the character movement again and set gravity scale back to the original value. So this will be useful here. Get old gravity scale and connect it. Now we will add grapple hook later. So in that too, we have some gravity logic. So we will check here later. We will check here if our grapple hook is on, and accordingly, we will decide whether we want to reset the gravity scale here or not. If you are planning to add grapple hook to your project, you might want to consider if this needs to be behind any branch or not. For now, this is fine. And after this, one more thing to note is sometimes I like to add a launch character node with 0 velocities and Z override like this, because as we have double jump, and sometimes while trying to wall run after double jump, the double jump does not complete. So the wall run starts before the double jump has completed, and at the end of the wall run, the character continues the jump from the previous interaction. So sometimes this node helps, but overall I don't like this, so I'm not going to be using it. Now, speaking of double jump, there's one more thing that we need to do. So before we start any of this, before we start any of the wall running, we also want to reset double jump again here that we have created in the previous video. So if you have followed it, you might want to follow along here as well. So we will create a custom event. We will call it reset jump and connect it to this reset in this toEnd node. Then we will get a sequence. Connect it in here. The second one we will connect as usual, and the first one we will use for reset jump. Let's comment our wall run logic. I will say wall run ability. Let's go over it once. Let's see if it works. So yeah, let's also make the wall. Okay, so get a new blueprint class. I will use the actor class and let's say BP wall for running. Let's open it. With this self-selected BP wall for running selected, let's look for tags. Now under actor tags, I will add the tag that we are using, wall run, without spaces, exactly as we have used it in the blueprints. Now I will add a plane. I like to use a plane instead of a cube because a cube sometimes just interferes with movement in my game, in my case. If you want to use a cube, you can try and see how it works for you. I will use a plane. Let's scale it a bit. So this is the forward direction. X is the forward direction. Let's press R and here you go. Let's make it big. And on the horizontally, or this will be vertically as we will rotate it. So breadth and length both. Let's make it big. Width and length. This should be fine, I think. And we can also use an arrow. So the arrow can help us with the direction of the wall. Now one thing you can notice is that the plane is not visible from the other side. To fix it, we will use a two-sided material. So let's make a new material. I will call it wall material. And inside here, we can see two-sided. I will tick it because yes, we want our material to be two-sided. And I will use a simple color. So I will press 3 on my keyboard. With 3 pressed, I will click. We get a vector. We get a constant vector or something like that. A constant. We can double click here and I want slightly yellowish color like this. Okay. And I will plug it in the base color. Save it. Apply and save. Now for the plane, we can use that material that we just made. So now it is visible from below as well. If we see, it is visible from below as well. So it is visible from both sides. Let's use this wall in our map. Before that, let's get some space. So I will select this wall and press E on my keyboard to rotate. So I will press R on my keyboard to scale and make it big. W to move. Let's get the wall. We need to rotate it. So E again. I will rotate it along the X axis 90 degrees and move it. So W. This looks fine. Rotate it again. E. And I want to rotate it like this for now. Let's see. It's a bit small. I want to make it big. Let's make it slightly bigger. We can use R to scale. Let's see again. Yeah, so this looks good and we can move in both directions. So that is a simple first person wall run. Next, we will add the ability to rotate the camera while we're wall running. So the effect looks a bit better. Now let's make sure that our camera rotates while we're wall running. So let's get back to the first person blueprint. And in the viewport, we want to add 2 more collisions with the capsule component selected, not the detect wall capsule. With the capsule component selected, let's add a collision, box collision. Let's name it wall detect left. Control D to duplicate it and name it wall detect right. Now, if you accidentally code it inside this, you can just drag it on top to unparent it. So these two should be at the same level under this capsule component. I will switch to the top mode, top view here, and with the right one selected and move it to the right. Right one to the right, left one to the left. Let's press R to scale, W to move, R to scale, and this looks good. So again, make sure that the left one is on the left side, which is top on it in my case here, and right one is on the right side, which is bottom in my case here. And if you want, you can make these smaller, but for me, I think I'm fine with the larger ones, but you can try to make it smaller because sometimes it can rotate the camera even when it is not wall running, because sometimes the wall can just overlap this detector instead of overlapping both of these capsule and the detector as well. For me, I think this is fine. Or let's just make it smaller. Let's see. Let's just make it smaller. Compile and save. Now in the event graph, with the right detector selected, let's look for on component begin overlap. We need to check if we are overlapping the wall. So actor has tag from the other actor. Actor has tag wall run. And we need to check if we are not on the ground. So is falling from character movement and boolean, then a branch. And we will need a timeline because we want to smoothly rotate our cameras. Let's say this will be rotate camera right timeline. True will be connected to play. And let's double click to go inside the timeline. Let's add a new track, add float track. I will call it alpha because we will use it with lerp. So timeline and lerp is just a combination of two nodes that we use to make things move smoothly. For this, the length will be 0.2. So it will run for 0.2 seconds. I want to add two keys. The first key, the time will be 0. Value will also be 0. For the second key, the time will be 0.2. Value will be 1. We can click these buttons to fit, and for both of these keys, I will right click and select auto because I want the curve to be a bit smoother. Compile, save, back to the event graph. Now let's also get actor rotation. I will split this node. We will use the X value here. So this is our player's current rotation. And we want to change the X value according to the timeline and lerp node. So connect alpha. X will be A. B will be -20 in case of right. So because we are rotating right, this will be -20. This is a number that works for me. If you want, you can try a different number. Lerp is for linear interpolation. Basically, in simple words, smoothly moving from A to B. So smoothly moving from this X value right now to -20 value along this timeline. When it updates, we want to set control rotation. So let's get the player controller. Here we want to set control rotation when it updates. Let's split this rotation. Now we have the X value, but we don't want to do anything with the Y values. So we want them to be the same as they were before. So we will get the rotation from our controller again. We will get the rotation, get control rotation, split the pin, and for Y and Z values we will use the control rotation values. So this is the logic for rotating our cameras while we are wall running. Let's add the logic for right detector as well. Before that, let's also make sure that we reverse the timeline, because when we get off the wall, we want the rotation to be the same as it was before we got on the wall. So with the wall detect right selected, let's look for on component and overlap. Again, we want to check if the other actor is the wall that we are talking about. So as that wall run, a branch. So if we got off the wall, we want to reverse the timeline. Now let's do the same for left as well. So with wall detect left selected, let's add on component begin overlap. And let's just copy all of this logic. Control C, Control V. Let's connect the branch. Let's connect the other actor to actor has tag. Timeline, let's rename this to rotate camera left timeline. Here this will not be -20 because this is left. The number that works for me is 20. You can try with a different number if you want to. This will be a positive number. And again with the wall detect left selected, let's look for on component and overlap. And we need to check if the other actor has tag of wall run and get a branch. Then we can reverse the timeline. Let's comment these. So I will say this is rotate right. Let's change the color. I want slightly bluish color like this. I'll save the color. Okay, this one. Press C to comment. I'll say rotate left. Color, blue color. Then I will select both of these. Comment. Rotate camera on wall run. Let's get these out of here. Let's say this is begin play. Enable plane constraints. Let's arrange it. That looks better. Let's see if it works. So our camera is rotating and we're able to smoothly wall run. The camera is rotating smoothly and this wall run is very nice. I love it. I like it very much. If the speed is a bit too much, you can try reducing it and see what works for you. For me, I plan to use this as a some sort of a boost wall run or something like that, so I will keep it like this for now. So that is how we can make wall run in Unreal Engine. If you like this video, please give it a thumbs up. Please share my videos with your fellow game devs and subscribe to my channel. I will see you in the next video. Hey guys, in this video we will add the ability for our character to jump off the wall while we're wall running. Hey guys, let's try to understand vectors, something about vectors that will be helpful for getting our player to jump off the wall while wall running. So let's say this is the wall and this is our player, and let's say this is the location of the wall and this is the location of the player. Now if we can get a vector from the wall to the player, if we can get a vector like this, and if we can get a vector like this, and we have a different vector with our wall like this, that is the right vector of a wall, that is the right direction of our wall, then we can determine in which direction to launch our player character to make it jump off the wall. So for example, if they are pointing roughly in the same directions, as we can see here, the dot product of these two vectors will be positive. But if they are pointing roughly in the opposite directions, as we can see here, the dot product of the vectors will be negative. So in this way, we can determine if our player is to the right side of the wall or to the left side of the wall. Now, how do we get this vector? How do we get this vector? We can see that we have a position for the wall and we have a position for the player. Or let's say we have a location for the wall and we have a location for the player. And let's say this is our vector A and this is our vector B. We have these two vectors. Now, what I want to find out is a vector, a different vector in this direction. So let's say this is A, this is B, and this is C. Now I want to find out C. What we can do is we can subtract this vector from this vector. So we can do A minus B, which will be similar to just adding two different vectors, which will be similar to adding the opposite of B. So if we just add these two vectors like this, we can get this C vector. So similarly, we can subtract the location of the wall from the location of the player to get a vector like this. And then we can use the dot product to determine if this vector and the right arrow is pointing to this in the same direction or in different directions, and then we can launch our character accordingly. We are in our wall run project in Unreal Engine. From the content drawer, let's open the first person character blueprint. Also, let's open the runnable wall blueprint. Now in this runnable wall, we can go to the viewport and see how our wall looks like. I want to add another arrow to this. So let's add an arrow component. Let's name it arrow right. If you have it inside this, you can drag it on top of it to detach. Also, I want to rotate it. So let's press E and rotate like this. Let's change the color to green. And let's also pay attention to this gizmo. You can see that this gizmo is like Z upwards, X forward, and Y to the right. But in our case, the right direction for our wall is downwards. because we have to rotate the wall while we're using it. So this arrow will be useful later to find out about direction. Let's go back to the first person character blueprint. And this is what we made in the previous video. So if we zoom in here, this is wall run ability. This other actor, I want to promote it to variable. Let's name it wall so we can reference it later. And let's move it here. So we want to do that after this branch. Now we also have to reset this variable when we end overlap. So let's go there. And we will set the wall to nothing. It will just be empty like this. We also want to make a custom event here because we will want to stop the wall run timeline when we are jumping off the wall. So let's say stop wall run timeline, and we want to connect it to the stop pin here. One more thing is previously this here was 2500. I think the speed was too much, so let's just change it to 1500. I changed it already. So this is a better speed for the wall run. Now let's get somewhere like here and zoom in. Let's make another custom event. This one will be the event. Let's name it something like jump off wall. This is the event that we want to use now. First, we have to check if we are wall running. So let's get the is wall running variable and also a branch to check it. Now we also want to get the wall reference here and we want to check if it is valid. So let's use is valid. We will use this one. After that, we have to get it again and we want to cast it BP runnable wall. We want to cast it to BP runnable wall because we want to access variables from this. So let's get the right vector that we added, right arrow that we added. It will be here under variables. We will get right arrow. And from the right arrow, we can get forward vector. The forward vector is the direction in which our arrow is pointing to. Now we have one vector. We want to do some calculations with vectors. So let's see. We will need some more vectors. Now we know that the direction that our arrow is pointing to. We want to know if this is the direction that another vector is pointing towards or away from. And what will be the another vector? It will be the vector that will tell us whether our player character is to the right side or to the left side of the wall. Something like that. So let's get the wall again. And we want to use get actor location. And again, we want to click here, right click here and use get actor location. So without anything attached, this will give us the location of this blueprint. That will be the first person character. And this is the location of the wall. Now what we want to do is subtract the wall location from our player character location. Now this gives us a different vector that can tell us the direction from this wall location to our actor location. We know that we can use dot product to know if two vectors are pointing in the same direction or different directions, similar directions or opposite directions. We will use comparison greater than. So we know that from the previous video, we know that if the dot product of two vectors is positive, that means they are pointing roughly in the same directions. And if it is negative, that means they are pointing roughly away from each other. Now let's select a number. We will use select int node for that. Based on this condition, if it is in the same direction, we are going to use 1. If it is in the opposite directions, we are going to use -1. And this is the number that we will multiply this forward vector from. So we'll multiply this forward vector with this number. So if the arrow and the direction from the wall to the player is roughly in the same directions, this will be the forward vector of the arrow. If they are pointing in roughly opposite directions, this will be a vector that is opposite or away from this forward vector of the arrow. After this, we also want to stop the timeline. So let's say stop wall run timeline. And we have to add some magnitude, because right now this is just a direction. We want to add some magnitude to it. So we will multiply it by another number. We want integer here. Let's multiply it with 1500. So we will multiply this vector by 1500. And now we can launch our player. Launch character. Let's split this pin. We can get the X and Y from here, but for the Z, I want to use a different number. I want to use 900, because we want our player to also go up a bit. Now let's connect it. Let's select this and press C to comment. Find direction to jump to. And let's say select this, select everything and comment jump off wall. I want this to be pinkish. Okay. One more thing is if we click on character movement here, I have changed the air control to 0.5. And you can obviously use different numbers here if this does not work for you, or if this does not look good. Now we want to trigger it, right? When we jump, when we use the jump action while we are on the wall, we want to trigger it. So let's go to the jump logic. So this is our double jump, and this could be another jump logic if you want to. We are using launch character node. In your case, if you haven't implemented this, it might be the jump node. So get a branch. I will hold B on my keyboard and click here to get a branch. We want to know if we are wall running. And if we are wall running, then we want to jump off wall. Else we want to do whatever we would normally do. And we can connect both of these here. Now both of these pins here go to the same launch character node. That is why we can connect both of these here. If you were doing something different, you could try connecting it with a copy of all of this logic and see if that works for you. If you are using a different speed for the second jump, for example, you can try something like that, but I don't need to, because in my case, both of these jumps are same. Compile, save, and let's see if it works. So it seems like it is working, and it is working from all of these directions, both of these directions, forward and backwards. So we can now jump off the wall while we are wall running. If it does not work for you, you can try swapping these numbers. If it does not work for you, you can try swapping these numbers. You, instead of 1, you can type -1 here, and instead of -1, you can type 1 here, and see if it works for you, in case you have followed different directions. So that is how we can add the ability to jump off the wall while we're wall running. Let me know what you think about this, and I will see you in the next video. Hey guys, I hope you're doing well. In this video, we will make our character go slower when shift is pressed and faster by default. Let's open the first person project and go to content drawer. Now let's open the first person character blueprint. Here, first let's organize these variables that we have. I will click this variable and I will assign a category to it. We will call it wall run. Now we will drop the remaining variables in this category because till now we completed the wall run ability. Now let's select the character movement component, and here we want to find max walk speed. Right now this is 600. By default I want my character to walk faster, therefore I will make it 900. Be careful of the units, it is 900 centimeter per second. If we compile, it will show that. Yeah. Now we want to make a new variable and we will call it old max walk speed. This will be a float. It will help us keep track of the old max walk speed when we change that variable. Now I want my character to walk slower when left shift is pressed. So let's add the logic for that. Let's right click here and look for left shift. And we have this keyboard event that we can use. Now I want this character movement component here, and we can get the max walk speed. Then we can set our old max walk speed to the one that we have right now. And after that, we can set the character movement's max walk speed to the one that we want on shift. I want it to be 600 because I want it to be slower on shift. Let's connect the pressed to set. Now we also want to set the max walk speed of character movement component. We want to set it to old max walk speed when the shift key is released. That is how simple it is to make our character go slower when shift key is pressed. Or you can change the numbers and make it go faster as well. Now let's select all this and press C to comment. Walks slow on left shift. Also, I will select this variable and give it a category as well. I will call it shift walk. It just helps to organize our variables. Also, one more thing that would be good to know is in the wall run video, in wall run ability, this was probably before the branch. I moved it after the branch. This node set the wall variable. I moved this after the branch just because this seems better. So if you have any problems with the wall run ability, you might want to try moving this node after this branch from here to here. Now let's check if it works. If I press shift, yes, it is walking slower, and if I release it, it walks faster by default. So that is how simple it is, and I will see you in the next video. Hey guys, I hope you're doing well. Today we are making dash ability in first person with field of view effects in Unreal Engine 5. So we have opened the first person project, and we will go to the content drawer. In the blueprints folder, we will open our first person character blueprint. In the last video, we added wall run and jump of wall and left shift walk abilities. Today we will add dash ability. So I want my player to dash when I press E. So I'll right click here and look for keyboard event E, and we have this E key here. Now when the E key is pressed, I want my player to dash. Now we need a variable, so let's make a variable. It will be a boolean. Let's name it can dash. Compile it. By default it will be true, so we need to check this because by default we should be able to dash. Now compile it again and save it. Now we need to get this here, and I will hold B on my keyboard and click, so we get a branch and we check if we can dash. If we can dash, then the first thing that we want to do is immediately set this variable to false. This will be empty, so it will be false. It will prevent us from just pressing E again and again and just messing it up. So yeah. Now I want to get my character movement, and from the character movement we want to get velocity. We will need it later. So right here we will get the velocity. Now we need a new variable. Let's promote it to variable, and we will call it old velocity. We will need it later when we reset our variables. Now from the character movement again, let's get it again. We need another variable that will be ground friction. So let's type get ground friction, because when we are dashing we want the ground friction to be 0. So we will need this variable when we reset the variables later. So let's promote it to variable as well, and let's rename it to old ground friction. Now we want to set the ground friction, so let's get the ground friction again, get the character movement, and from there get the ground friction again. This time we are setting it, so let's set the ground friction. It will be 0, so our ground friction will be set to 0. Now I want to get our first person camera, and let's see where we are looking. by getting forward vector. So we will get forward vector. This is the direction in which the camera is looking. I want to multiply this by some number. I will multiply it by a float. So let's convert the spin to float. I want to multiply it by 5000. You can try different numbers. This will be the velocity of our character movement. This will be the velocity that our character will have when we're dashing. So let's set the velocity of character movement to this one. Now I will need some space because here we will add some nodes for field of view effect later. So let's drag from here, and this seems nice. Let's add a delay node. This will be for how long that will be dashing, and by default 0.2 seconds seem nice to me. Now again, let's drag from here, leave some space because we will be doing something here later. And well, we don't need to drag just yet, wait. So let's get the character movement again. Now we need to reset the variables that we changed. So let's reset the ground friction, set ground friction to the old one and connect it. Also, let's set the velocity to the old one. And I also don't want to just be able to dash again right away after we just finished dashing. So let's add a cooldown. Make a new variable. This will be a float. I'll call it dash cooldown. This will be a float. Compile it so we can set it. This will be 2 seconds. I want to wait 2 seconds before being able to repeat dash before we can dash again. So let's get it and add a delay node here. So we will wait for dash cooldown and then we can dash again. So we will set the can dash variable to true again. So this is our dash ability right now without field of view effects. Let's see if it works, and then we will apply the field of view effects. Okay. So back to the viewport. Let's try to play it. If we press E, and if we press E again and again, well, it does wait for some time. Yeah. Well, so yeah, I think 2 seconds is good for the cooldown. So we cannot just keep dashing again and again very quickly. Alright, so now let's add the field of view effects. Before that, let's just select all of this and press C to comment. Let's say this is dash ability. Here is the blueprint for that again. Now let's organize these variables under a category for dash. So I will click any of these variables that we have for dash, and in the category I will type dash. Press enter. Now drop the remaining variables. Now this is under dash. Very nice. Now here I want to make a custom event which will be for starting field of view effect. So let's add a custom event and we will name it start FOV. Now we need more variables. Let's get one more variable. This will be has applied FOV. This will be a boolean. So by default it is false because by default we have not applied any field of view effects yet. We get it. Now we want to check if we have not yet applied FOV, so we can apply it. So for that we need to drag from here and look for not boolean. Then we can press B on our keyboard to get a branch and connect it. Then immediately we set this variable to true because we do not want to just do it again and again in a very short time and mess things up. So yeah, that's why we have this variable. Now we get the first person camera and we get field of view. Now we want to promote it to variable and call it old FOV. We will need it later. Now we need a timeline because we want to smoothly change the field of view of our camera. So let's add timeline. Let's name it FOV timeline. Now we will double click to get inside it and length will be 0.1 seconds. I want to add a float track which will call alpha and we need two keys here. So for the first key the time will be 0 and value will be 0 as well. For the second key the time will be 0.1 and value will be 1. That is our timeline. Now we need a lerp node as well. This will help us smoothly change the field of view along with the timeline. So we connect the alpha here and we also get the old field of view, that will be A, because we are going from this old field of view to a new field of view. We want to change the field of view by 10, so let's add a number to it. It will be 10 and this will be B. Alright, and now we need to get the first person camera again. Now we need to set the field of view. So when we are updating, we need to set the field of view. The output of the lerp node will be the input of the set field of view. Now we need a branch here and we need to check something. So we also need to reverse this, right? Let's connect it first. So yeah, we have this connected. Now if this timeline has been playing in reverse, which we can check from the direction, so if we just press equal, so we have this equal enum here. That is what we need. I want backward. So if our timeline has been playing in backward, that means it was reversed, and when it was completed, when it was finished, that is what when we want to check this. So when it was finished, if it was playing in backward, that means our field of view effect have been reversed. So we want to reset this variable. Set has applied field of view to false. Also, to trigger that, to actually reverse it, we need a new event. So let's look for a custom event. This will be stop field of view, stop FOV. We need to check it if we have applied FOV. Only then we want to be able to reverse it. If we have applied FOV, then we will reverse the timeline. And when the timeline finishes, if it was playing in backward, then we want to reset this variable. So we want to be able to apply the field of view again. That is why we have to reverse this variable, reset this variable. Now that is the blueprint for our field of view effect. Let's select it and proceed to comment, and let's type FOV effect events, enter. Let's drag it down a bit. Alright, that looks good. Let's go over it again. Let's see if it works. Compile, save, back to the viewport, play it. We'll press E. Oh yeah, we need to actually trigger these events. So here, where we left the space before the delay and after it. So before the delay, we want to start FOV. And after the delay, we want to stop FOV. Also, let's organize these variables. I will click it, and in the category, I will say field, let's just say FOV effect, and drop this here too. So now we have these variables also organized well. Let's see if it works. Compile, save, back to the viewport. If we press E, yes, so our field of view is changing. So now we have a dash ability with a field of view effect and a cooldown in first person in Unreal Engine 5. I actually like it. If you like it, please let me know in the comments, and I will see you guys in the next video. Have a great day. Hey guys, today we will make smooth crouch, uncrouch, and sliding in Unreal Engine 5 in first person. Let's get started. In our first person project, let's go to the content drawer and blueprints folder, open the first person blueprint. Now this is the event graph, and we need to add smooth crouch and uncrouch abilities. So first we will Select our character movement and look for crouch. Here we need to take this can crouch movement capabilities, I guess, and yes, we want to be able to crouch, so we will tick this, compile and save. Let's zoom in here and let's make 2 custom events. So custom event, add a custom event, we will name it start crouch. We also want to have one more custom event and we will name it end crouch. Now I want my character to crouch and uncrouch when left alt is pressed. So let's look for left alt. When it is pressed, I want to start crouch, and when it is released, I want to end crouch. Let's select it and press C to comment. I'll say left alt crouch and crouch. I want this to be blue. Now we need a timeline as well. So let's make a timeline. And I will call it crouch timeline. Let's double click to open it and we will make the length about 0.2 seconds. And we will add a float track. We will call it alpha. There will be 2 keys. And for the first key, the time will be 0 and value will be 0. For the second key, the time will be the length, which is 0.2, and value will be 1. Let's fit it and make it smooth. So we will select auto to make the curve smoother. Compile, save, and back to the event graph. Now we have this timeline. Also, remember what we need to smoothly change something, a combination of timeline and a lerp node. So we will connect alpha here, and when we start crouch we will play it. When we end crouch we will reverse the timeline. Now we need to get our character movement and get the crouched half height, and we plug it to B. Now there's one more thing that we need to do, and for that we will need to go to our begin play event. So let's find, so this is our begin play event, and here we need to get our capsule component, and we need to get capsule half height. Now we will promote it to variable and we'll call it old capsule half height. We will need it later when we reset our variables. Now get back down there, and this will be our A. This is the height of our, this is the half height of our capsule component, and we will be changing this. So when we update it, we need our capsule component again. We need to set capsule half height. The return value of our lerp node will be the half height, and let's connect it to update of the timeline. Double click here to make it look better. So this will smoothly go from this old capsule half height to crouched half height over 0.2 seconds. And while we do that, we change the capsule half height. But we also need to do one more thing, because doing just this will not help our character crouch. So when we finish, we're going to need a branch. So let's hold B on our keyboard and click to get a branch. Now we need to compare the direction. Equal, equal. We need this enum equal. We need to do that when we finish the timeline. Double click and drag to make it look better. So if our timeline was playing in forward when it finished, that means we want to crouch. So let's just type crouch. That will make our character crouch. And if it was not forward, that means it was playing backward. We need to uncrouch. So that will help us smoothly crouch and uncrouch. Technically, we could just plug these into left alt and our character would crouch and uncrouch, but that is not smooth. Because we want a smooth crouch and uncrouch, we need to use a timeline like this and change the half height of our capsule component over some time smoothly using a combination of the timeline and lerp node, like we always do. Now let's select all of this and proceed to comment. I'll call it smooth, crouch and uncrouch. Let's compile, save, and go to our map plate. Let's see, will it work? So if we press Alt, yes, the crouch is smooth. If we release it, the uncrouch is also smooth. So that is how we can add smooth crouch and uncrouch to our first-person games in Unreal Engine. Now let's also add the ability to slide. So back in the blueprint, now let's get some space, and right here we're going to make a new variable. So let's make a new variable that will be a boolean by default, and we will name it should slide and crouch. It will be a boolean by default and it will be false by default. Now we need another custom event. Let's name it start sliding. So first add a custom event. We'll call it start sliding. Now we also need one more custom event and we will name it end sliding. Now end sliding will just be the end crouch event. So let's just end crouch, because while we are sliding, we also want to make sure that we are crouched. We are not going to be sliding without crouching. So yeah, and in start sliding event, we are going to make a slide change. That will be, we will set should slide and crouch to true, and then we will start crouch. Now I want my character to crouch and slide when I press the R key. So let's look for the keyboard event R, and when it is pressed, we will say start sliding. When it is released, end sliding. So when it is released, we will say end sliding. Let's select it, press C to comment. We will say start sliding and end sliding custom events. Here we will say, let's press C and sliding on R key. I want this to be a little bit orange like this. So somewhere like here, right? Now here we want to look for event on start crouch. We also need one more boolean variable. Let's make one more and name it is sliding. By default, this will also be false. It will be used to track whether our character is sliding or not. Let's get it and also drag from here and look for not boolean. So if our character is not sliding right now, and we also need this should slide and crouch variable, let's look for and boolean. So if our character is not sliding and we should slide and crouch, let's hold B on our keyboard to get a branch. Then first we need to set these variables to true. So first we need to set this one to true, is sliding to true, and should slide and crouch to false. Then we need to get our character movement and get ground friction. We need to promote this to variable, and let's name it crouch hold friction. Then we need to set ground friction to 0 so our character can slide smoothly. Now we need to get a character movement again and look for max walk speed crouched, promote it to variable, and rename it to old max walk speed crouched. Then we want to set max walk speed crouched. For me 1200 works. You can try with a different number if you want to. Now let's select all of this and press C on our keyboard and comment start sliding on crouch if should slide and crouch. And I want it to be slightly blue. Now we also want to stop sliding, right? So let's look for event on end crouch. Now we want to check if we are sliding, so we will get is sliding, and then we will get a branch. Then we will set is sliding to false, and we will get our character movement. Then we want to set the ground friction to crouch hold friction, and we also want to set the max walk speed crouched to old max walk speed crouched. Let's select all of this and we press C to comment, and we'll say stop sliding on uncrouch if currently sliding. I want this to be blue as well. Now let's select all of this and press C. Let's say logic for handling crouch and sliding. Also I want this to be blue as well. Why this is orange as well, we might change it later. So yeah, let's compile, save, go to. Also let's organize our variables. Let's click on one of these and in the category let's say crouch and slide. Let's drop the remaining variables here. Now our variables are also organized well. The viewport and try if our character can slide. So first, can we crouch? Alt key. Yeah, the crouch is smooth and we can crouch. Now if we press R, we can crouch and uncrouch. But what if we are running? If we press R, we are able to slide, and we can feel the friction is very like little or zero, I guess. Yeah. And we can release the R key and get back to our running mode, or press it and slide. So that is how we can add smooth crouch, uncrouch, and sliding in Unreal Engine 5. Let me know in the comments if you like this, and I'll see you in the next video. Hey guys, today we are going to improve our uncrouch logic so that our character does not uncrouch under these objects. And when it comes to outside, it uncrouches again. Alright, so let's open the first person character blueprint. And we will go to the viewport. Now I want to make a capsule collision here. So let's add a capsule collision. Now I'm going to name it uncrouch capsule. And this is our main capsule component, this one, the right above. And we can see that its half height is 96 and the radius is 55. I want at least the radius to be the same. So here let's make the radius to be 55. Now in my case, I actually also want the half height to be same as radius. Now let's look at it from left. And in first person template in Unreal Engine, the thing is our character's origin is in the middle instead of being at the bottom. What that means is when our character crouches and our main capsule changes in height, this uncrouched capsule will also, like, its origin will also change. It will go slightly down. Now that can be a little bit difficult to deal with in Unreal Engine first person template. So we have to make sure that it is at a height where when our character crouches, the uncrouched capsule is roughly at the height of the normal uncrouched capsule height of the character, if that makes sense. Well, if you don't understand it, don't worry, we're going to actually look at it in the game inside the viewport. So for now, this is the place that I found, and the radius will be 55, but you might try adjusting the half height of the capsule according to whatever seems fit for you. For me, 55 works with the default settings of the first person character. Compile, save, and in the event graph, now let's with this uncrouch capsule selected, let's get on component begin overlap, and with it selected, let's get on component and overlap as well. Also with this selected, let's just make sure that in collisions it is not generating hit events. So in collisions it is not generating hit events, but it is generating overlap events, and the collision preset is overlap all dynamic. Now on begin overlap and on end overlap, we want to make sure that we ignore self, so we don't count the overlaps of first person character with first person character, or of this capsule component with other components of our first person character. For that, let's get a branch. We will hold B on our keyboard and click. Now let's get the other actor here. Now we want not equal, and we also want a reference to self. So if the other actor is not equal to self, only then we want to proceed. Now we want to make a new variable. Let's say uncrouch overlap count. This will be an integer. Compile, save. By default it is 0. And when our character begins overlap, what we do is we get it and then we increment it by using plus plus. Now we need to do this check again when we end overlap. So let's copy it and paste it here. Control C, Control V, and connect the other actor. Here what we do is we decrement it, so we get the uncrouch overlap count and we do minus minus, so decrement int. This variable is keeping track of how many times our character has overlapped another object. Now we need event tick, so let's get event tick. Before that, let's also make a new variable, and that will be wanna uncrouch. It is going to be a boolean and it is going to be false by default. Now what we need is we will get this and we will check if this is less than equal to 0, and we will get AND boolean, and we will get this as well connected here. So if we are not overlapping anything, if the uncrouch capsule is basically not overlapping anything and we want to uncrouch, then what we are going to do is let's get a branch first. So hold B on our keyboard and click to get a branch. Then first thing, immediately we're gonna say we will set this variable one uncrouch to false, and then we will set the uncrouch overlap count to 0. Then let's make a custom event. We're going to need a custom event here. Let's make a custom event. This one we will say do uncrouch, and we trigger it here. So do uncrouch. Let's cut it, Control X, and go to our uncrouch logic here. Let's paste it, Control V, and connect it to reverse. Let's hold Alt and click to break this link, and when we end crouch, all we do is we set the wanna crouch to true. And before we start crouch, we also set wanna crouch to false. Now that is the change that we need to make here. So I think this should work. Yeah. So let's try to test it. Go to the map and let's just click here. Hold Alt on our keyboard and drag to duplicate it and bring it here. But before we can try to test it, let's just have it on a similar height as this. Looks fine. Before we actually try to test it, let's make sure that this can actually overlap. So here let's search for, with this With this mesh selected, let's search for overlap, and we need to tick this generate overlap events. Now let's also duplicate this again. So hold Alt on the keyboard and drag. If we duplicate it, it will have the overlap ticked already. Yeah. Now let's make it slightly downwards. Let's see if it works. We will play, and if yeah, we can get under it, and I just released the Alt key, and let's get out of it, and we uncrouch. So this seems nice that we can get under things, and if we uncrouch, we don't just uncrouch inside it, we will uncrouch after we get out of this. Yeah, so to actually understand how to set up this capsule, let's just take a look. So first click here and look for hidden in game. I want to uncheck it, and then also select the main capsule. I want to uncheck this as well, so we can see both of these capsules in the game. Now what we want to do is go here and drag our first person character here. Let's play the game. What we can do is go close to it and press Alt. Then we can press Shift F1. Actually, to visualize it, let's just go back to the event graph, and for now let's go to the uncrouch logic and break this link because we want to see something. Let's play again, and if we uncrouch and then we press Shift F1 to get our mouse pointer and pause the game, and we detach from the player controller, we can move here. Now we can see that when we are crouched, so we can see that when we are crouched, the top of this capsule, this uncrouched capsule is almost almost at the same level or slightly higher than the top of our main capsule. So that is what we want to do. Why does that happen? Because in first person character, the origin of the character is from the center and not from the bottom. So when it crouches, the origin of everything else also shifts accordingly. Therefore, we want to make sure that our uncrouched capsule is set at a height such that when our character crouches, the top of our uncrouched capsule is slightly higher than the top of our main capsule, just slightly higher. Let's press escape key and we will remove this. So press delete to remove it, and back here, let's connect the do uncrouch to reverse again. Compile and save. So that is how we can make this sort of smart uncrouch logic in Unreal Engine 5. Let's select all of this, press C to comment, and let's say check for overlaps for uncrouch. I want it to be slightly blue, and here let's just say this is our event tick. So select it and press C to comment event tick. I want this to be blue as well. Let's select all of this and press C to comment improved uncrouch logic. Another thing is when our character goes inside these objects, sometimes the camera can clip into the meshes. So if we just try to here, the camera can clip into the meshes sometimes. So what you can do for solving that is, let's get it here, perspective mode. So what you can do for solving that is select the camera and try to adjust its position, try to move it down or up according to whatever works for you. For me, that is not an issue, so I will not move it from this place. Yeah, so another thing to keep in mind is that we should not have these meshes at a too low level. Like, there should be enough space such that the camera doesn't clip into it. Also, let's go back here and select this uncrouch capsule. Let's look for hidden in game, check it, do the same for the main capsule, and we're done here. Also, let's organize these variables. So let's drop these under crouch and slide. Now our variables are also organized. Hey guys, I hope you are doing well. Today we will make a trampoline in Unreal Engine in first person. Let's get started. So we are in our first person template. Let's click on content drawer, blueprints folder, and here we want to make a new blueprint. Let's use the actor class. Let's name it BP Trampoline. Double click to open it. Here in the viewport, I want to add a cube. Let's name it Trampoline Mesh. It can be any other mesh as well. And for the cube, I want to scale it by 0.1. Scale it to 0.1 on z-axis. Compile, save. Now also let's look for the collisions. Here, simulation generates hit events is off, generate overlap events is on, and collision presets will be overlap or dynamic. And then if we scroll down, we can use on component begin overlap. Here let's check if the other actor is actually the player. So we can do that by casting it. Cast to character. It will be BP first person character in our case. And if this check passes, then we will drag from here and launch character. So we want to take this Z override and we want to have 2000 here on the Z velocity. In launch velocity, Z component will be 2000. Now we also want to be able to move the trampoline. So for that, let's make a custom event. Let's call it move trampoline. Here we will need a timeline. I will name it trampoline timeline. And we will play it from start. Let's double click to get inside it. The length will be 0.8 seconds. Let's add a float track. I will name it alpha. And we will have 3 keys. So let's add 3 keys. For the first key, the time will be 0 and value will be 0. For the second key, the time will be 0.4 and value will be 1. For the third key, the time will be 0.8 and value will be 0. Let's click here to zoom and we can scroll. Let's make it smooth by selecting auto on all of these keys. Compile and save. Let's go back to the event graph. Now we need a lerp node. Let's connect the alpha and B will be -100. We will be changing the relative location in the Z direction of our trampoline mesh by -100. So let's get the set relative location. We will split the spin and connect the return value to Z, and we will do it on update. Now we also need to trigger this event, right? So let's trigger it here before launch character and after we cast the other actor. Move trampoline. And that is all. That is all that we need. Let's select it and press C to comment. Here we will say move trampoline timeline event. Let's make it blue. And here we will say launch character on overlap. I want this to be blue as well. So our trampoline is ready. Let's try it. We can drop it here. And if we untick these, we can change the transform smoothly, or we can tick these to snap it. I want this to be scaled horizontally a little bit, so let's press R and just select these. This looks fine. Save it. W. Press W to move. And let's have it somewhere like here. Let's try it by play. If we jump on it, it goes down and we go up. So that is how we can make a first-person trampoline in Unreal Engine 5. Let me know what you think about it in the comments, and I will see you in the next video. Hey guys, I hope you are doing well. Today we will make a grapple hook in Unreal Engine in first person. So let's get started. So we are in our first person template in the first person game that we are making, and we will go to the content drawer. In the blueprints folder, let's open the first person character blueprint. Here let's go to the viewport. We need a cable component, but before that we also need a scene component to tell the game where our cable component will start from. So let's add a scene component. Now I will call it Grapple start location. And now here we can add a cable component. I will call it Grapple cable. Now with this grapple start location component selected, let's change the view mode to top. So here I want to move it somewhere like here, because I want the grapple hook to come out of the left side of my character. Yeah, so I think this is better. Here the position is -70, -70, 0. So this looks like a good position for our grapple hook. Now with the grapple cable component selected, first let's change the material. So for now I will just select the first person projectile material. You can use a different material. For me this looks good in the demo. And here in the end location I want it to be 0 and not 100. So let's also look at it from perspective mode. This is how it looks right now. And we want the end to be attached to this component. What is the component? Its name is Grapple Start Location, exactly the same name. So this is the component that we want our cable's end to be attached to. And if we scroll down, we do not want our cable to be visible by default, because if we look down we can see it doing nothing basically. So when it's not in use, we don't want our cable to be visible. Alright, now let's go to the event graph and let's zoom here. So first we need event tick. I am already using the event tick, so we will go here. If you're not using it, you can make a new one and start from there. So here first we will add a sequence. So if we hold Control and then drag, we can connect it here, and then we can promote this to variable. We will need it later. Also, let's connect it to the first pin in sequence. So that helps us with the delta seconds variable, which we will use later. Now let's get some space. So we want to grapple when F is pressed on the keyboard. So let's look for keyboard event F. But before that, we also need a condition. So let's make a Boolean variable here, can grapple, because we don't want to be able to grapple again and again. We want a grapple cooldown. So yeah, let's make this variable, and by default it will be true, because by default we can grapple. Now let's get it, check for it using a branch, and then we need to immediately set it to false. Now we also need one more variable to keep track of whether we are currently grappling. So let's make a new Boolean variable, and it will be is grappling. By default it will be false. Let's set it to true, because now we are grappling. Now let's get the character movement. Because we have changed the gravity in our project, we need to set it to normal. So let's set gravity scale, and we want to set it to 1. Then we need to look for a surface where we can grapple. An easy way to do that is using a line trace. So we will use a line trace by channel. The start location will be the character location. So from our character to some distance, let's get our camera, because we want the direction to be where our camera is currently looking. Let's get its forward vector. This is the direction that our camera is looking. Now we need to multiply it by some number. Let's multiply, and I will change this to float. Let's promote it to variable, and let's call it grabble distance. Compile it, and the default value, let's try 3000. You can try a different number. Now here we need to add it. So this displacement, this distance, we need to add it to our actor location in the direction of the camera to get the end point of the line trace. Now let's draw debug type. Let's say this is for duration, so we can see what is happening. Now if we go back to our game and we stand here and press F, we can see that we have a line here which is deducting if some surface is in the view. So now let's continue, and now let's check for this value if we actually hit something, if the line trace hit something. We will check it using a branch. And if we hit something, let's get where we actually hit, the exact location. So for that, first let's break the hit result. And if we click this little arrow, we can see this location. Let's promote it to variable as well, because this is the exact location where the line hit the object. Let's call it grapple location. Let's collapse this node as well. Now we need a custom event. Let's make a custom event. Let's call it shoot grapple hook. We will use this event to actually shoot the grapple hook, and then we also need one more event. Let's make one more custom event. Let's call it reset grapple hook. This will be useful in resetting the variables that we change when we start our grapple hook. Now here, if we actually don't hit anything, if the line doesn't hit anything, then we want to reset our grapple hook. We will make this event later. And then if we actually hit something, then we want to shoot the grapple hook. We will make that event as well later. Now we want to launch our character. Before we actually send our character to the grapple location, we want to launch it off the ground a little bit, just a little bit. So in the Z direction, let's add 500. And I want to override X, Y, and Z. Then we can add a delay. And then we can launch our character again. And here we are going to do a very simple approximation. So as we know that speed is actually, let's say, velocity. Velocity is displacement divided by time. And let's say we want our character to reach a particular point in 0.4 seconds. We will get the displacement and divide it by 0.4 seconds. And dividing by 0.4 is equivalent to multiplying by 2.5. So we will get the displacement and then multiply it by 2.5 to get a rough estimate of the velocity that we need for our character to go from point A to point B. Now, because the time is short, the gravity doesn't act as much on it, so we can afford this approximation. This is not the best calculation actually to go from point A to point B in Unreal Engine, but it works for our project, so we will use that. So let's get the grapple location and subtract the actor's current location from it. Get actor location. This is the displacement that we need to cover. We will multiply it by a float, which will be 2.5, which is 1 divided by 0.4. And we can connect it to launch velocity. And then we can actually have a field of view effect, which we have added before. If you have not added before, you don't need it, but because we have it, so we will use it as well. Start FOV. And then we will have a delay for 0.4 seconds. Then we will stop FOV. You don't need to start and stop FOV if you don't have these field of view effects set up in your project. You can directly just add the delay and continue. Then here as well, we need to reset the grapple hook. Now you can try this 0.2 second delay, but I actually don't like it much. So I'm going to change it to 0 actually. And because we changed it here, we don't get a lot of time. So we need to increment this delay just a little bit, to allow us to climb the walls or the surfaces that we're grappling to. Just a little bit. For me, 0.45 works. You can try with 0.5 as well, or whatever works for you. File and save. Let's comment these. So I will select this till here and press C to comment. Let's say check for target. I want it to be blue. And here, let's select these and press C to comment. Let's say grapple to target. I want this to be blue as well. Now let's select all of this. Move it down a little bit, then press C to comment. Let's say start grapple hook. Now let's make these events. So first we will make this shoot grapple hook event. So we will get our grapple cable and we will set visibility, because remember we set the visibility to hidden before, so we will set it to true right now. It will be visible from now. Then we will make a timeline. Let's call it grapple timeline. We will play it from start, double click to enter it, and I want the length to be 0.5 seconds. Let's add a flow track. Let's call it interp speed, and let's add 2 keys. Actually, for the first key, let's say the time is 0 and value is 30. For the second key, let's say time is 0.5 and value is 30. This is the speed by which our grapple hook travels from our location to the distance. You can try changing these, or even having a curved graph if you want, but this looks fine for me right now, so I will use it. Let's go back to the event graph, and now we will use a node called V interp 2. Let's get grapple cable again and get world location. This is our current location. Let's plug it into current location. What is the target location? It is the grapple location, so let's get it and plug it in. Delta time, we set it in the tick event, so let's get delta seconds. Let's plug it here, and let's plug the interrupt speed as well. Now let's get the grapple cable again and set world location. So this code actually moves the grapple cable that we have. We do that on update. Let's plug the return value to new location, and that is our shoot grapple hook event. Let's select all of these and press C to comment. Shoot grapple hook event. Now let's make the reset grapple hook event. So when we reset our grapple hook, we want to change its visibility as well. So let's get the grapple cable and set visibility. We want it to be hidden, so we will set it to false. Now we have wall running in our project, so we will check if our character is wall running. If you don't have it, you don't need to do this, but because we have wall running in our project, we will check for it. So if we are wall running, then we will set the is grappling to false. And if we are not wall running, then first we will set the gravity scale. Let's get the character movement and set gravity scale. And then we will set the is grappling to false. What will be the gravity scale? We have the old gravity scale, we will plug it here. Now after that, we will wait for some time. Let's add a delay. Let's promote it to variable and call it grapple cooldown. This will be the delay before we can grapple again. So compile, save, and then we will change it to 2 seconds. So grapple cooldown will be 2 seconds. And then we will be able to grapple again. So let's set can grapple to true again. Let's select all of this, press C to comment, and say reset grapple hook event. Let's try it. It is working, and we want to disable this draw of this line trace, and we also want to add some lift to our character, or let's say add some upwards velocity to our character when we collide with these walls, so it can help us climb them. Let's go to the blueprint, and with our capsule component selected, let's say on component hit. With the main capsule component selected. Now we want to check if the other component is simulating physics. Let's get a branch. And if we are not simulating physics, that is if it is a static asset, if it is some static asset, we want to check if we are grappling. So let's get that. Get a branch. So if we are not simulating physics, then we want to check if we are grappling. And if we are grappling, we want to launch character. So let's say we will override X, Y, and Z, and the launch velocity will be 600. You can try different numbers if you want to. And just for debug, let's print text. Let's say we will print hit. Let's select this. We will select till here because we will delete this one, and proceed to comment. Let's say climb wall at end of grapple. Let's try if it works. Compile, save, go to the viewport and play. So if I press F, yeah, we do have some upwards velocity after hitting the target. Let's go back to the event graph. And here, let's say draw debug type is none. Compile, save. And we're done here. Let's check. So if we come here and try to grapple, so yeah, we can grapple and things are working. Let's grapple and wall run. Yay. So let me know what you think in the comments, and I will see you in the next video. Hey guys, let's add realistic camera shake to our project for idle, walk, run, and jump. Let's get started. Let's add realistic camera shakes to our first person project. So in content drawer in the blueprints folder, let's make a new folder and we'll call it camera shakes. Open it by double clicking. And now let's make some camera shakes. So we'll make a new blueprint and under all classes we will look for legacy camera shake. Select it and let's call it idle. Now we will duplicate it and we'll call it walk. Again we will duplicate it, we'll call it run. And we are going to make one more for jump, and that would be camera shake base, and let's call it jump. Now let's go to idle. Now here let's change the oscillation duration to 0.25 and in the oscillation let's change the pitch amplitude to 0.5 and frequency to 2, and let's scroll down and tick this single instance. Compile and save it. Now let's go to walk. Again the oscillation duration will be 0.25, pitch under rotation oscillation, amplitude will be 0.4, frequency will be 12, and yaw, the amplitude will be 0.2, frequency will be 9, roll, the amplitude will be 0.2, frequency will be 6. So for example, so if it moves in this way or in this way, so nose up or tail up, that is pitch, side to side movement is yaw, and a circular clockwise or anti-clockwise movement of the body as it moves forward, that is roll. Again let's take this single instance, compile and save. Now let's go to run. Here the oscillation duration will be 0.25 and pitch amplitude will be 0.8, frequency will be 18, yaw amplitude will be 0.6, frequency will be 9, roll amplitude will be 0.4, frequency will be 7. And let's take the single instance, compile and save. Now let's open the jump. So here we have to select a pattern. Let's select wave oscillator camera shake pattern, and here in the location we have to say 0 and 0. The location amplitude and frequency multipliers will be 0. And for the rotation amplitude multiplier will be 1. And here pitch amplitude will be 2, frequency will be 2, and initial offset will be 0. And in yaw, amplitude will be 0, frequency will be 0. And in roll, amplitude will be 0, frequency will be 0. And in timing, let's say duration will be 0.4, and that is it. Let's compile and save. Now let's go to the blueprint. Let's open the first person blueprint, and here we will need a new event. Let's say we need a custom event. Let's call it camera shake. Now here we will need a branch, so we will hold B on our keyboard and click. Let's connect it. So we need velocity of our character. We're going to get its length. And we will compare it. So if the velocity is greater than 0, that means we are either walking or running. And we're going to check if we are actually standing on the ground or we can jump, for example. So let's use an boolean and let's say can jump. Now we'll plug this in the branch. So if it is true, we're going to need another branch. Here we're going to check the speed. Again, let's get velocity and vector length. Now we're going to check if this velocity is less than equal to some number. So we know that greater than 0 and less than equal to some number. In my case, that number is 650 because my sprint velocity is around 900 and walk velocity is around 600. So I want something slightly larger than 600 but much smaller than 900, for example. You can try changing number, but make sure be careful while changing it according to your sprint velocity or run velocity and walk velocities. Let's plug it in. So get player controller. And then we can drag from here to client start camera shake. Now we're going to duplicate this. We can press Ctrl D to duplicate this. We're going to need 2 more. Let's plug in the target. Now if it is true, we're going to play this one. And which one will it be? This will be walk. And if this branch is false, we're going to play the next one, which will be run. And if the first branch is false, we're going to play the last one, which will be idle. That is the logic for camera shakes, for idle, walk and run. Let's select it, press C2 command, and let's say camera shakes for idle, walk and run. Now we need to trigger it in event tick. So let's go to our event tick. So our event tick is here. Now we're going to add one more pin here. And here we're going to call our event that we made for camera shake. So that is the custom event that we made. If you don't have this setup, you can just connect it directly to the event tick, for example. We just need to call this event in the event tick. Now for the jump one, let's go to the jump logic. And here when adding double jump, we added an event on landed. We're going to use this one. If you don't have this double jump logic, you could just look for event on landed, for example. So here we are going to add a sequence because we have this connected to a different node as well. So let's add a sequence. Let's connect it. First one, we will do what we're doing before. And for the second one, we can start a camera shake. And let's say and start camera shake. Let's select jump. And let's organize it a little bit like this. Now let's try play it, and this is the idle one. I'm going to hold shift on my keyboard and walk. So this is our walk camera shake, and if I run, this is our run camera shake. And we can jump, and when we land, this is our jump camera shake. So that is how we can add realistic movement camera shakes in Unreal Engine 5 in first person. Let me know what you think about this video, and I'll see you in the next one. Hey guys, let's make first person vaulting or wall climbing in Unreal Engine 5. And this is how it looks. Let's get started. Let's open the first person project that we're making, and inside blueprints, let's open the BP first person character blueprint. Here we are going to make a new function. Now let's call this function vault trace. Here we are going to do a line trace from player to a distance to check if there is an obstacle in our way or a wall to climb. We could do this trace in the event graph, but we're going to use this trace in one more place, so let's just make it a function. Here we are going to do line trace by channel. Now start location will be our actor's location, so get actor location. And to get the end location, let's get actor forward vector. This is the direction that our player is facing. Now we need to multiply it by some number. I'm going to multiply it by 100. So let's convert this pin to float. 100. You might want a different number. So this is how long I want the line to be. Now we need to add it, and the result will be the endpoint for the line trace. Now let's compile, and we want to add some outputs. So we want the out hit and return value to be an output. For that, let's add a hit result struct. So here we can see the type is hit result structure. So change the type to hit result structure, and let's just say this will be out hit results. And let's add a boolean. This will be a boolean, and let's say this will be hit boolean. File, save. Now this is the return node that gets made here, so let's get it and connect the out hit result and result value to hit boolean. Also let's connect these pins, and that is our vault trace function. Now let's also draw it for duration so we can see the line. Now let's get back to the event graph. Here we will make a custom event, and let's name the event vault. So we need a new variable. So here we had these variables that I just put under Grapple Hook category. You can click these. If you have these, you can click these and set the category, type it here. So let's make a new variable. This one will be a boolean, and let's say canVault. Compile, and by default canVault will be true, so let's tick this. By default, when the game starts, we canVault. Now we need to check it, get a branch, and if we canVault, we will immediately set it to false because we don't want to spam the vault. Now let's add a timeline here. Let's say this will be vault timeline, and play from start. Here we will use the vault trace function. So in update, we will get the result of our trace. And you could break the out hit results. So you could, for example, break hit result and see all of these variables, and then you could put a tag on an actor and then check the tag here. But I'm not going to do that because I want my character to be able to climb basically everything. So I'm not going to do that. You could, for example, do this actor hashtag and then use it in a branch, for example, but I'm not going to do that. I'll just check this boolean. So if you did that, if you checked for the actor hashtag, you would use an and boolean to also check this, because this is important. This is what tells us that whether our line hits something or not. So I'll just use this. Let's get a branch. It is automatically connected. And if it is true, what we're going to do is we're going to launch character. This will add some velocity to our character in the Z direction. I'm going to go with 900. You can choose a different number for the Z direction here. Most probably you will need a different number because I have set the gravity scale to 2.3 in my project instead of 1. So my project has higher gravity than normal. So I'm going to use a higher number. For you, I think something around 600 or even less might work. And I'm going to tick these. So we will override the X, Y, and Z velocity. You could try not overriding the XY velocity and see how it goes, but to keep it simple, I'm going to check this. I'm going to override the XY velocity as well. Now, if we did not hit anything, if the line trace did not hit anything, then we want to stop the volt timeline. So let's get the volt timeline. We could click here and say get volt timeline, or you could also get it from components here. You could also get it from here. Get volt timeline. Same name as here. And we will stop it. So if our line did not hit anything, we will stop the timeline. Now we need one more custom event. So let's make a custom event here. Let's say this will be reset volt. And here we will reset the variable that we changed. So can volt will be true again. Let's also quickly update this timeline. So double click the volt timeline to get into it, and here the length is for how long we want our character to be able to climb, and I want it to be 0.5. You could try with different numbers, but my character will climb for at most 0.5 seconds, at most 0.5 seconds. Okay, so here in the event graph, for example, it will stop it if our line does not hit anything before 0.5 seconds, or it will complete the timeline in 0.5 seconds. Alright, so let's reset it and also trigger this. Before that, let's select all of this and comment, press C to comment, and say volt / wall climbing events. This can be a nice wall climbing ability as well, or it is, I guess. Compile, save. Now let's go to the jump logic. So we'll go to the top. That is where our jump is, here. So we have this event on landed. If you have not set it up like this, if you do not have double jump like that, you could just get event on landed by typing here event on landed, and you can directly connect the pin that I'm going to connect. So we have this sequence here. We will add a pin. If you don't have it, you could just directly connect it to reset volt. Now we also need to trigger volt, right? So in this jump action, we're going to need to trace the line and check it using a branch, and based on that we will either jump or vault. So here first let's do the vault trace. So we will drag right from here. Okay, it automatically connects that way. So after doing this vault trace, we also need a branch. So let's get a branch from here. Okay, that way it automatically connects like that. Here let's check the hit boolean, and we don't want to connect through here, we want to connect the false here. Okay, for true we are going to just do the vault. That is the custom event that we made for vaulting, and we don't want to connect this here, so let's break the pin by holding Alt and click. So yeah, okay, make sure it is not connected to this event node. All right, so if this condition is false, then we will do what we would normally do. If it is true, then we will vault. Compile, save, and let's see how it looks. So if we go here, for example, and I'm going to press spacebar, if we can see this line trace here, we hit something. So yeah, let's do it. And we need to hit W. Okay, we need to press W to go forward. So we will press W like that, and we're able to climb. So we can see, for example, here. Right, let's make a big wall and see if we can just spam the vault. I'll press R to scale and I'll make it very big. Let's see what happens now. Alright, so if I'm here, I'm going to press W and wait, I need to be closer. So yeah, so I go up for almost 0.5 seconds, and not after that. If I try to spam it, what happens? So I cannot go further than that. All right, so you could try adjusting these numbers inside the launch velocity node. Here you can try adjusting this and see how you like it. You can also try adjusting this number in the timeline, and that is how we can make easy wall climbing or easy vaulting function in Unreal Engine. Yeah, also let's organize our variables. So for example, here we can select the can vault and say category, it will be vaulting. So our variable is organized now. And also let's go to the vault trace function, and I'm going to say draw debug type will be none. All right, now let's check. Let me know what you think of this, and I will see you in the next video. Hey guys, I hope you are doing well. Today I want to make sure that we are using only one key for crouch and slide. And I also want to make use of enhanced input actions instead of keyboard events. For example, here we will be using an input action instead of the shift key. We will be using a dash input action instead of the A key, and same for the crouch and same for the grapple. Why we will be using enhanced input actions? Well, it is just nice to have, nice to use enhanced input actions, as it helps us support many different kinds of inputs, and it makes our blueprints easier to manage. So let's get started. Let's open the first person character blueprint, and let's go to the event graph. Here let's look for our crouch and slide logic. So here end sliding is just end crouch, and when we press R we start sliding. Now I want to use the same key for crouch and sliding, so we will just remove this R here to select it, and we will delete it. Let's look for Alt. So this is the key for crouch or uncrouch. So here we are going to need a branch. Let's get some space. We will hold B on our keyboard and press. And if the branch results in true, we're going to say start sliding. If it is false, we're going to start crouch. And when we press, we will check that. Now what we will check, what exactly we will check? We're going to check the velocity of our character. So let's get it. So we can get velocity and vector length. Now we can compare it with some number. So let's say if this velocity is greater than some number, what will be the number? In my case, it will be 650. If we go to the camera shakes, we have used that number because my normal walk velocity is around 600 and running velocity is around 900. I have changed it in the character movement here, so we have changed it here. So I'm going to compare it with 650, and if it is greater, then we will slide, else we will just crouch. Alright, let's try if it works. So if I press Alt, I'm crouching, and if I just go ahead, we have the normal movement here. Alright, so what if I'm walking and then I press Alt? So we start sliding, and if we release Alt, we stop sliding and uncrouch as well. So that is nice. Now if I'm holding Shift and then I walk, then I press Alt, we just crouch. Alright. But if I'm running and I press Alt, we slide. And this is nice. Now we will first let's adjust it here. Now here in the event graph, if we look, we have some keys like left shift, E, left alt, and F. Instead of directly using the key events, I want to use enhanced input action events. So let's do that. Let's make some input actions for our keys. So if we go to first person input and actions, we already have some default inputs here. Let's make some new ones. So from input, let's make an input action. And let's name it IA. This one will be for shift walk, so let's just say shift. Let's open it and make sure it is digital boolean. So boolean is like on or off, and here axis is more like mouse input. So for keys, I'm just going to use this digital boolean type here. Save it. And I'm going to use one more, so let's make more. Oh, let's just duplicate it. I'm going to select it and press D to duplicate it. I'm going to say IA dash. Now we will duplicate the dash, and here we will say grapple, and we will duplicate the grapple. Here we will say crouch. Now let's go again to first person input, and we will go to IMC default, as this is the mapping context for these default actions that is already used. So where it is used, let's see. If we go to the blueprints and if we open the controller, we can see that on begin play, this mapping context IMC default is added to the enhanced input system. So we are just going to edit it. Let's go back to actions, input. Let's go back to input and IMC default. We're just going to edit it. Let's get it here. And I'm going to add some more mappings. So for example, this is jump. Let's add dash, and this will be E. Let's add crouch, and this will be left alt. This will be left alt. Let's add grapple. This is going to be F. Let's add shift walk. So shift, this is going to be left shift. So here, this is going to be left shift. We can click this little keyboard and press the key that we want to use for this input. So again, let's check. We have for dash, keyboard event E, and we have for crouch, left alt, we have for grapple, F, and shift, left shift. Save it. Now we can go back to our first person character blueprint and let's change those. So here we can start by double clicking on these keyboard events and we can go there. So instead of left shift, what I want here is IA shift. So this is the event that we want. Let's click this little arrow to expand it. And pressed is started. So I'm going to just over here, hold control, and we will grab it and connect it to started. All right. Again, we will hold control and grab this pin and we will connect this wire to complete it. Now we can get rid of left shift by deleting it. We're going to do the same thing for others. So for E, this is the dash ability. So I want the dash action here. So let's look for IA dash. So this is the event that we want. When it is pressed, let's connect this one to started. So we will over here, hold control and grab it and connect it to started. All right. Now we can get rid of this E event. Now let's find more. Left alt. This one is for crouch. Let's, instead of saying left alt, let's get the crouch action here. So IA crouch, that is the one that we want to use. And we will do the same. We will grab it by holding control and connect it to started and complete it. You can get rid of the left alt. Now let's look for more. F. This is for grapple. So let's get the IA grapple. This is the event that we want. And instead of pressed, let's grab it by holding control and connect it to started. We can get rid of the F key here. And that is all that we have. Let's compile and save. And we will check if everything works. So let's check if everything works. Let's play the game. And if we walk, we can walk. But if we hold shift and if we release shift, so the shift action is working. But if we dash, if we press E, that is working. And if we press F, we can grapple. Now if we hold Alt, we can crouch. And if we are running and we hold Alt, we slide So everything seems to be working. Let me know what you think about this video, and I will see you in the next one.